let's try an example.
Okay.
So let's see if we can find the flux of f is x plus y, 2x minus c, c cubed, through the triangle with corners at j and k.
Okay.
Cool?
Yeah.
All right. So flux suggests that I do what?
Surface.
Okay.
Integral of f dA.
So I need the integral over a surface of f dotted with dA.
Should probably figure out the corners of that triangle.
Okay. Yeah, we should probably draw a picture or something to maybe help us along. So the corners of that triangle are
1, 1, 1.
I, J, and K, right?
Yeah.
So I's over here, J's back there, and K's up here. So there's your triangle.
A nice little 45, 45 triangle.
But where's it?
Equilateral triangle.
I'll stop it with the angle it's sitting at.
Oh yeah, it's sitting at very convenient 45s.
Where's it sticking up?
There's so many triangles in this picture. Right, because there's the one I'm talking about, the one that kind of cuts through all three axes, and then there's the ones made in each pair of planes, right? So that, or pair of coordinate planes. So that XZ plane, the YZ plane, and the XY plane.
Yeah.
But the triangle I'm interested in is this one. Right, the one that kind of cuts through everything in a slant. So what do I need to, so this was my idea, right? I wanted to execute a flux integral.
You need a normal vector first.
Yeah. So the execution of that should be I need to integrate over the surface f dotted with a normal vector, some d area measure, right? Okay. So what's your normal vector on this thing?
We could go from equation of the plane.
Yeah.
Good. Okay. So I want a plane, right? It passes through 3 points, or how else could I get that?
Well, IJK.
We can find the slopes.
Well, the slope would just be 1, 1, 1.
The normal vector would just be 1, 1, 1.
Oh, okay.
You guys see that?
Yeah.
Yeah.
Right? It's symmetrical.
Yeah.
And so the thing that sticks straight through it is that 1, 1, 1 vector.
Okay.
You guys see that?
Yeah.
That's cheating on this one. Normally you take 2 displacement vectors, cross them, there's your normal vector, right?
Oh, okay.
So if we took 2 displacement vectors, right, those would look something like this. Let's see, that's the x and y displacement. So maybe here's the y, the x and z displacement.
Yeah. Yeah.
Right? So take these, cross them, you'll get the vector 1, 1, 1. So let's just operate with the vector 1, 1, 1. Is that the thing I want to put in here for a normal vector?
No,
Yeah.
No,
it's not unit length.
it's too long.
It is.
How long is the vector 1, 1, 1?
Root 3. Yeah.
Perfect, square root of 3. So I need to adjust. So I'd like to say this is the integral over S of my vector field, x plus y, 2x minus z, horrible z, comma z cubed, dotted with 1, 1, 1, right?
Yeah.
Root 3 and 1 root 3.
Perfect. Except down.
Let's do it.
1, 1, 1.
Scale multiplication.
Yeah, and then, so what do I need to do with the 1 over 1/3? Or
Just
1 over cube root of 3?
Take it out. Take it out.
So that wrong 3 times. Take out a 1 over what?
1 over root 3.
Root. Perfect.
Scale multiplication. Yay.
Cool. So in general, right, if you have a nice easy form for your normal vector, don't mess it up by trying to force it to be a unit vector, just compensate out here. It's only going to be off by scalar multiple anyway. So that
Done.
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 Or
Got
again,
it?
we should put the bounds in our integral.
Okay. So this is 1 over the square root of 3 bounds. weird happened, right?
Don't we-
It seems like I should have 3,
Yeah.
right? Because I have 3 variables in my vector field. Right, so if I did this dot product, I've got x plus y plus 2x minus z plus z cubed.
Oh,
And I'm trying to integrate this dx dy or some jazz.
yeah.
So I got some issues. You guys help me straighten them out?
Negative triple integral.
But that would just be a volume which we're not looking for.
Yeah, I'm looking for a flux, fundamentally, right?
Do we take away the z?
No.
How can I get rid of the z, right? That's my problem. There's a z in here, I don't want it.
Could we substitute?
With what?
Like
Oh, just
2x.
Y equals 2x minus z.
Or y equals negative
Z.
x. Or x, not what x is.
How about on the surface, right? You guys see that?
Uh-huh.
On the surface, z is something.
Is
Oh.
equal 2x minus y.
No,
I don't know if it's 2x minus.
z equals
oh.
2x, and then there's z cubed.
How about what's the equation of this plane over here?
Well, that's 1 minus y.
So it should be x plus y plus z.
Equals 1.
Equals 1.
So then z equals 1 minus.
So z is 1 minus x minus y.
Okay. So then it'd just be from 0 to 1 minus x minus.
Or no, we plug that in for z.
Okay, so that goes in for z. That's good.
Ah.
So I got 1 over the square root of 3. Integral from 0 to, I don't know.
Well, we flattened the triangle.
Yeah, so it's just from 1 to 1 now.
Not in both, it's not.
Oh, really?
So, and then I found out what z was, right? So
Yeah.
I've got x plus y, how about 3x plus y minus whatever this stuff is, 1 minus x minus y, plus 1 minus x minus y cubed.
Okay.
I knew I shouldn't have put that in there. dx dy, right? And now I need to sort out my bounds of integration.
You can always take it back.
I think we can solve this anyway. We maybe won't bother with this integration because I don't want to cube that thing.
Yeah,
But at
that's
the very
not-
least, we can get an integral set up here.
Yeah.
So right now I want these guys.
Mm-hmm.
So if I smash this thing down, right,
Mm-hmm.
I got rid of the z's, so where do the x's range?
0
Oh, 0 to
1 minus y.
Yeah, 0 to 1 minus y.
Perfect. This is the line x's, right?
Dx,
Yeah.
yeah, 0 to 1 minus.
So this is the line y is 1 minus x.
Yeah.
So that x's, they range from rearrange. Perfect.
Yeah.
So from 0 to
1 minus y.
1 minus y, and then where do the y's range?
0 to 1.
0 to 1. Perfect.
So we're squishing it with our substitution for z.
Yeah. You guys see that? Really what I'm doing is I'm parameterizing. Yeah.
Up from the 2x of the both equation, you just drop that.
Went somewhere.
I had x plus 2x negative 5.
Oh, okay, I didn't see that.
No, just arithmetic. Cool. So really what I'm thinking here, right? If I was thinking super hard, I'd be thinking of a parameterization of x and y, right?
Mm-hmm.
And it'd look like x and y and 1 minus x minus y.
Yeah.
You guys see that?
Yeah.
That would actually make my life easier, so maybe we should do that. If we could think this way, it would make our lives easier, so
Yeah.
should we learn to think that way?
Sure.